No enterprise customer ever wants to have maintenance activity related disruption for their compute. On the other hand, in reality, for any hyperscaler, including OCI, there are always tons of maintenance activities going on at any given point, whether it be security related or hardware maintenance related. How do we actually do all of these activities without impacting customers? That's where OCI VM live migration comes in. Welcome to First Principles video and blog series. I'm Pradeep Vincent, SVP and Chief Technical Architect for OCI. In the First Principles series, we talk about in-depth technical architecture about how we build various subsystems in OCI itself. Today, we're going to talk about how we build OCI live migration for virtual machines. Here to talk with us about that, we have Neil Soman, who's our main architect for OCI Compute. Welcome, Neil.
Good to be here.
Obviously, we have lots of maintenance activities going on, and we use OCI live migration as a very important tool to protect our customers from impact of those maintenance activities. Tell me a little bit more about live migration. What is that all about?
So live migration essentially involves moving a running virtual machine from one physical server to another, right? But we want to do that so that there is no customer impact. So from a customer's point of view, nothing really has changed, just that their VM is now running on a different machine, and the source machine VM can actually be torn down.
This is really cool. I mean, it's almost like you're moving a house from one location to another and actually disrupting all the utilities, taking out all the utilities, plugging them in the other side, except that we don't even tell the people who are living in the house. And they actually don't see an impact. It's almost like magic.
Exactly.
So how exactly does live migration work?
When you're talking about a virtual machine and its state, there is really two types of state associated with it. There is the persistent state, which includes things like data that's actually on block devices that are attached to the virtual machine, as well as things like the contents of the NVRAM. There's also runtime state, which includes actual guest memory pages, as well as state that is associated with devices that are connected to the VM. And then there's also runtime state at the OCI's network virtualization layer, the VCN layer.
Got it. So it's almost like persistent state. If there's a power cycle, that'll all remain. Runtime state, it's like things that we're going to lose if there's a power event. Both states are important, and we need to make sure that they're preserved during this live migration process so that the applications don't feel any impact. They just run as if nothing has happened.
Yep, exactly.
Is that reasonable?
Yep.
All right, cool. Let's actually take one of these. Let's take runtime state.
So runtime state, the biggest piece of runtime state is the memory pages, the actual RAM that's in the guest VM. That has to be copied over to the destination. Now, the way we do this is kind of interesting. We keep the source VM running, and we will keep copying memory pages to the destination. And then when most of the memory has been copied, we take a short pause, and then we copy over the rest of the runtime state.
What do you mean pause? Pause for what?
The source VM is paused, and the additional runtime states, such as device state, which is really small, is atomically copied over. Because we do need that atomic piece in order to make sure that there's consistency.
Got it. So essentially we have a running state. There's several minutes where memory is copied over, perhaps recursively. And then we have a pause state where the VM, this is actually where customers are going to see a very small impact. And we do multiple things to minimize the impact. And during this time, rest of the runtime state is copied over, not just memory, but also other types of runtime state. And finally, we thaw the other side. And that's, essentially from a VM perspective, they keep running, and then they just start running the other side. Is that
that's
cool?
That's essentially it.
Let's talk a little bit more about the memory copy itself.
There are a couple of ways to handle copying memory in the industry. One way is post copy, in which the destination VM is started right away, and memory is actually paged in from the source. Now, the advantage to this is that you do not require any pauses. The destination VM is essentially resumed right away. There are a couple of trade-offs associated with this, right? One of the trade-offs is that you're actually going to perceive some performance penalty because you have to now page memory in over the network. There's another piece that is another trade-off has to do with your state is now distributed across 2 physical servers, right? So that's a little bit less resilient. So what we decided to do is we decided to focus on resiliency, which is why the approach we pick is pre-copy. In pre-copy, what the hypervisor is doing is that as the VM is dirtying memory, it will keep track of that by protecting the guest's address space. And then it will keep copying that memory over while the source VM is still running. What this does is that it lets us back out of it at any point.
Got it. If you're like recursively copying memory from one thing to another, and if the source VM dirties the pages quite fast, you may not be able to converge. You may not be able to successfully copy a lot of pages. How do you deal with that with pre-copy?
That's actually one of the trade-offs with pre-copy. If your VM is really using the memory a lot, if it's reading, that's fine. If it's writing a lot of memory pages, then that process may not converge. So what we essentially do is that we have some safeguards built into the system so that if you're not converging, we'll just give up and try later.
Got it. We choose not to give any availability impact to customers. Instead, we just fail the live migration very safely, and customers don't even see it because they don't see live migration anyway. But there's no impact if you're struggling with the memory copy, we just stop and
exactly.
Get rid of the process, and customers don't see any impact.
Yep.
Right. Cool. Awesome. So apart from memory, what else is there in the runtime state?
Yeah. So in addition to the memory, there's also state that's maintained for all the devices that are attached to the VM. That's typically small. The hypervisor handles it. It has mechanisms to essentially save and copy and transfer.
What type of memory are you talking about?
It's state associated with actual virtual NICs, storage devices. It's state associated with vCPUs. Anything that's basically on the system bus that state has to be extracted and copied over.
Got it. So essentially, it's apart from the memory or the RAM itself, we have various little memory states that are embedded in virtual devices or maybe even physical devices that need to be transferred over. And that's essentially part of the runtime state. And we essentially do all that as part of this process.
Correct.
Cool.
Yep.
So what are the types of persistent state and how do we actually deal with that?
The biggest piece of persistent state is actually the remote block volumes, the data that's on block devices, right? So the way this is handled, we're not actually copying that around. It actually sits on the block storage servers. What is done is that we're establishing a network path from the destination VM to the block storage backend, right? So we create these attachments as part of the migration process while the source VM is still running. The destination VM is not running yet, so nothing is reading and writing. Now we have a little bit of a challenge once we resume start the destination VM, because what's going to happen is that there might be stale write IOs in flight from the paused VM that may actually conflict with write from the destination VM once it's resumed. And so what would happen if those bytes arrive later? They will get written and we'll have data corruption. To mitigate that, we implemented a fencing mechanism. What this lets us do is that the block storage backend actually detects when the destination starts using it and is able to reject the stale write IO from the source VM.
Got it. So frankly, it's relatively easy because it's more of a centralized storage anyway, and it has its own replication mechanism and whatnot. And both the VMs can essentially talk to the block storage pretty much at the same time. Just that when the flip happens as part of the live migration, you just need to fence the IOs so that some stale IOs then don't get commingled with the brand new IOs. And that's why we have the fencing mechanism.
Exactly.
Awesome.
Yep.
Cool. What other persistent state?
In addition to that, we also have the contents of UEFI variables, NVRAM. That's also migrated during that pause phase.
Got it. Okay, cool. Any other persistent state that we migrate?
There's also the actual VM's config itself, because you don't want to have devices appear out of order, right? Whatever's attached has to appear exactly the same way.
Cool, awesome. So how do we do the networking part?
So for network state, there are a few pieces to this, right? So I talked about device state, the runtime state, right? So this is a little bit different based on what type of network device is used. If it's paravirtualized, the hypervisor is actually in the data path between the VM and the host kernel, right? So it's able to extract and restore state in that case. For pass-through devices, it's a little bit challenging because essentially the hypervisor is not in the data path. Now, what we're doing for this is we're going with this new industry standard that's called VDPA. It stands for vHost Data Path Acceleration. In this case, what's done is essentially it's a VirtIO interface that's exposed to the VM itself, but it still allows for pass-through functionality. So the data path and the control path are essentially split. And so what happens as part of migration is that the actual hardware, the NIC and the hypervisor cooperate in order to extract and restore state.
Got it. Essentially, there are two options here. We have a paravirtualized interface, in which case it's actually, fairly easy because hypervisor is in full control. It can actually detach that and then move to the other side, and VMs are not going to see a big difference because it's paravirtualized. And then you have a SR-IOV case where the VM is directly talking to the NIC. But in this case, in general, it's going to be hard to live migrate because there's state on the physical NIC, and generally it's hard to transplant that in a safe fashion. But with VDPA design, we actually have a mechanism to get in the SR-IOV channel and actually observe the state and transplant them as part of live migration. Right. Cool. What else do we do to make sure that the networking migration goes well?
Yeah, so that was the state that's at the host itself, right? There's also state in OCI's VCN layer. So what we do, there are a few pieces to this. One of the things that we do is that we actually pre-create the network configuration for the destination NICs while the source VM is still running. Right? We want to avoid latency, so that's done ahead of time. There's also flow state in the network virtualization layer. This includes connection state that's part of OCI security rules and security infrastructure. If that is not transferred over, we would essentially drop established connections, right? So the connection state actually has to be preserved. Otherwise, stateful firewall rules won't be preserved. So that's actually done. That's small, and so that is done as part of the VM pause. We also make sure that we don't want to drop any packets, ingress packets. So ingress packets are forwarded from the source to the destination before the destination is actually started.
Got it. Cool. This sounds good. So we have a lot of things going on as part of the live migration process. We have memory, we have other types of runtime state, we have persistent state, block, we have networking. It looks like a complex coordination that needs to be done across all of this. How do we actually do it?
Yeah, that's a great question. So we just saw a bunch of these primitives, right, at different layers. There has to be some brains behind this to orchestrate it. That's done as part of a control plane service. It's called Live Migration Orchestration. What this service does is talks to these various pieces to drive the migration process. So for example, it will tell the hypervisor on the destination to pre-create the VM, but not start it yet. It will then tell the hypervisor to start the memory copy process. It will instruct virtual networking to copy flow state and forward packets. It will also work with block storage to implement fencing. And then at the end, it will tear everything down once the process completes.
How do you actually make sure that customers don't see any impact? How do you make sure that, as an example, how do you make sure that all the network bandwidth used by the live migration process doesn't actually impact customers?
Yeah, great question, right? So as we saw, there's a bunch of memory that needs to be copied, right? And so that state tends to be big. So what we do is we actually reserve bandwidth for migration itself on our servers. That way, you're not causing a noisy neighbor problem as part of the migration itself. So that's one safeguard. Another safeguard as we saw is that we use pre-copy. That means that we're able to basically restore the source VM at any point without losing any memory state, right? And then another thing that we did is that to actually make sure this all works, we created a fault injection system that essentially in pre-production, as part of development and testing, we inject faults into every piece of this complex process. We make sure we can actually recover from that situation.
Yeah, I'm pretty sure. I mean, this is not going to be obvious, but the error injection process is actually quite important, right?
Exactly.
To really make sure this is, it doesn't impact customers as part of it. That's awesome. Cool. So essentially, to summarize, we use OCI live migration quite extensively to protect customers from various types of maintenance events in OCI. The crux of it is essentially, for a large extent, as we copy the state, the VMs are left untouched, and the customers continue to run, and they don't really see any impact. They don't have to do anything about that. What we do is, as part of this design, is to essentially move all the runtime state as well as all the persistent state in a very safe fashion. The safety being the key, right? So that customers don't have any impact, they don't see any problems, their block IOs continue to work, they don't see a lot of drop packets, they don't see any drop connections. So we essentially have technology investment to make sure that all of the state is transferred transparently. Cool, awesome. Well, thank you very much for joining us today, Neil. Thank you for joining us.
Hey, did you like what you learned? Make sure to check out this video or this link, and of course, subscribe now.